All right. Good morning, everyone. Yeah, they're coming in. I hope you are all doing well. We are going to wait just a minute to make sure everybody is getting in, and then we will begin.
I'm sorry about that. Trying to adjust my camera.
Panelists, if you could please mute yourselves when you are not talking, that would be great. Thank you. That'll help with some of the feedback. As I said, good morning, everyone. Thank you for joining us as an introduction to microtechnologies. We are going to wait just one more minute to make sure everybody is getting in and getting settled. All right, we are going to go ahead and begin. Thank you all for being here again today. My name is Jamie, and I am an assistant product manager here at Millennium, and I'm going to be your moderator today. So please, if you have any questions at all throughout the presentation, use the Q&A function down at the bottom of your screen and chat away. I will make sure all of those questions get answered for you by our panelists. So to begin today, we have David Johnson Jr., who is our Dura-Line Microtechnology Specialist. And joining him, we also have Tim Lowry from AFL and Frank Saccone from GMP. I am now going to kick it off to David to begin today. Thank you all again for joining us.
Thank you so much, and we're super excited for today. It's been a long-awaited event that we've been planning, and it's great to be a part of the Millennium team and what they've been doing. And I just want to show gratitude to them and the opportunity to be here and be in front of you guys. This is exciting technology. It's really something that has grown, over the last decade. So I'm going to start sharing my screen here, and we'll kind of dive into this and kind of get going here. And just verify that we're seeing this all right.
Yep, we got it. Thanks, David.
Okay, perfect. So as you guys know, we're going to be learning about microtechnology today and really the evolution of the pathway and the evolution of micro cables and fiber and jetting equipment and what that entails today. So as you guys know, with the events of 2020 and COVID, we've really learned that we're moving to a more connected world. We've all experienced Zoom meetings like this. We've experienced the need for better bandwidth at your homes and in rural areas. And just the way it is today, we need more bandwidth. Our customers need more internet. We need more services in areas that we haven't been to in recent years. And technology like microtechnology really is the solution. And it allows us to really replace any issues that we've had in the past with our technology and our internet services. You guys could probably think on the amount of devices you have connected at your home. I know I've got 30 plus devices connected on one router, and at times it can be a little overwhelming for that bandwidth. So it's really something that's necessary for us, the way this world's growing with added devices, better iPads, better iPhones, better technology. It's just something that we are needing in this world and in the US. So really our presentation's about how microtechnology can answer those questions and can allow our customers to upgrade their system with lower construction costs, lower restoration costs, better upgrade costs, maintenance, and really reducing the size of pathways we're putting in the ground. Really kind of going towards the government request of dig once, right? So, we really want to share these technologies with our customers and with you so you guys can understand how it can benefit you here today. So the stuff that we're going to be talking about today with microtechnology and our value proposition is really these threefold, right? You get higher fiber density in a small package, lower installation costs, and the ability to have future expansion, right? And as you're going to learn, there's names of these products that really are explaining what they're for and how they're here to help us experience better bandwidth in our networks. So here, what's great about this is you might ask, well, where are we using this stuff? Where is this micro technology being used? And the answer is every single aspect, every single market, every single vertical market you can think of. Fiber to the home, long haul, going from city to city, multi-dwelling units, rail systems, all of these things you see on the left here. This technology can show added benefits and a smarter way to build your networks. On the right here, you see customers that have adapted to this technology with Millennium. These are very close customers to Millennium and what they've experienced in the recent years using this technology. So when we talk about microtechnology, we talk about not only the pathway with Dura-Line, we talk about micro cable, we talk about boxes, closures, and terminals, and placing equipment. All four of these things play a critical role in what microtechnology means and how to successfully install it into your network. And we've got other panelists here from AFL and GMP, and those individuals will be talking here shortly to really help you guys understand their part of their technology. But this is something that we are going to go over. And then after we go over these four aspects, we'll start talking about how and where we can use this material and what products you would want to select for a certain given situation that you have. So to start with, we're going to start with the pathway and microducts and future path. And it's always good to have definition, right? So when you're learning a new technology, it's good to understand the terminology and what certain things are called. In this industry, in the US, we're used to 1 1/4, 2-inch conduit, SDR 11, Schedule 40, Schedule 80, where when we talk about microtechnology, a single tube, a single pathway looks similar to what I'm trying to show you here. My background kind of can mess with it a little bit, but this microduct, this is a single microduct here. Every single one of our microducts that Dura-Line makes has all these features here. They have super silicore. We have ribbed in lining to really eliminate any surface area that the fiber is touching as you're placing it into the microduct. We make it in all materials. We make it in HDPE, we make it in riser, plenum, low smoke, zero halogen, all of which is wherever the environment that you're placing these ducts into, whether that's in building or outside plant, we have the product available in all shapes and sizes. The sizes you see on the right here are the majority of the sizes we sell. We do have one extra one that's a 2720, but how we talk about microducts isn't by 1 1/4 anymore because they're so small. We go by the OD and then the ID. And as you see there, it's super important for you to know that you got to say two numbers. Sometimes you can see there's multiple 10s, whether they're the OD or the ID. And it's super important for all of us to really understand that definition and how to really understand which microduct we're talking about that we would like to use in our network. Diving a little bit more into the technology that we at Dura-Line have, right? So this is a trademark solution with Dura-Line. We have a product called Super Silicore. It's a permanently embedded product. It's not lube. It is permanently embedded, extruded into the inside diameter of all of our microducts. And the benefits of this is to have less friction. It allows us to place fiber in the ground through 90s, through 45s, through bends, ups and downs, left and rights, eliminating as much friction as possible, allowing that fiber to glide through the pathway and get long distances and quicker speeds. Next definition we have here is future path. So when you see bundled microducts, whether that's in as you can see on this screen here, whether that's a 2-way, a 3-way. We have 4 ways and 7 ways. This product is FuturePath is bundled microducts. So when you have one or more microducts into an oversheath, we call that FuturePath. It all has a protective oversheath. That oversheath there is for installation purposes. So as you're installing that into the ground, all those microducts are staying together. They're not twisting, they're not turning, they're not spinning, they're not causing any kinking, and it allows it for an easy install. Then inside of this FuturePath bundle, it comes with a standard 20 gauge locate wire. So anybody who's done, all of us have done builds in the past, you have to have a locate, right? So 1.25 inch, you might have the locate on top of the 1.25 inch, or you might be just bearing it alongside. This is a product that comes with it, which allows you to save cost and money in installing your network into the ground. They come with rip cords as well to easily remove that oversheath. And we have tools that we'll talk about later and how you can use those tools to better open up the FuturePath as well. So the important thing here is now that you got our definitions, right? Microduct, FuturePath, it can be very overwhelming when you learn this for the first time and see this shot here, all the options we have. Really, the biggest thing for you guys to understand as customers is we can make a product specific to your needs. And we'll talk about where these are, used down the road here in a second. But this is just kind of an introductory of really we can make a product and set it really perfect for your network and your design and what you're doing as a customer and your network build. Going on evolution of the pathway, right? So this just kind of shows you really kind of what Duraline's trying to do, along with Millennium and partnering with each other and showing our customers really what we are doing in this industry. Really changing the way that we think and how we place our conduits in the system. So you see right here on the left, a 4-inch black conduit with 3 1/4 inside. That's something that we definitely have pushed over the years and have used many times and still do today. But with this FuturePath situation that you've got, you can place in 3 7-way FuturePaths and have 21 pathways. And as we all know, we're always trying to find ways to add added capacity and build for the future. And this is a great way to do that. When customers are working on indoor buildings, multi-dwelling units, this is huge in large cities. And this is something that just kind of shows you having a pathway dedicated to each individual tenant cleans up a lot of things, cleans up a lot of installation that you do. And it really can help restoration. We'll talk a little bit more about MDUs here shortly later on as well. This photo is a good photo. We all, when we're making a network and we're building, part of that is the large picture, right? Well, what kind of yard am I going to place my conduit and my fiber in? Do I have a big enough yard? What's great about this photo here, and it just emphasizes really your space, the space factor of FuturePath. And this is 7, 1.25 inches on a reel that are 1 mile in length versus 1 mile in length 7-way, right? So it's a space saver. It allows you to save freight cost as well when comparing to traditional conduit to FuturePath. So we're gonna, now that we've talked about the pathway, good introduction, and once again, we'll talk about applications here in a second. We'll dive into microfiber now and what that entails and the technology that has changed here. So as you can see on this first slide, you have a picture on the far right there with the 1.25 inch and a standard standard fiber cable. And then on the left, you have 4 different configurations of FuturePath, 2 4-ways and 2 7-ways. And really, it's just showing you the density, right? That these are all 144 count fibers. The overall OD versus a standard cable and a micro cable is at least 1/3 the size, and allows you to have a lot more density in the same size package as an 1.25 inch.
Hey, David, we have a quick question.
Yes.
Do you need lube to blow fiber with Silicor? Would you still recommend using it?
That is a great question, and yeah, we do. It's a different type of lube. It's not the same lube people are used to. You know, if you are a contractor and you are jetting now in the industry inside of standard inch and a quarter, you do use jetting lube. So you just need to make sure you're using a jetting lube. And within the micro duct, there is a specific lube for micro duct and micro jetting. So as long as you're using a micro duct jetting lube, then yes, it is always good to have the lube. That Silicor actually just enhances that experience and allows you to really make sure you're successful when placing fiber. Great question.
Great, thank you.
All right, and so just go, keep asking questions, and you know we'll answer them as they come in, and appreciate the dialogue. Everybody's got these questions, which is awesome. Also another space and size and weight factor here with fiber, right? We talked about the reels of duct. This is what the reels of micro cable look like. You've got a standard reel here, and the real important thing to look at is the weight, right? You've got 3,200 pounds there, and then you've got 560 pounds versus a microfiber reel. So that just really emphasizes how much people on site, how many men on a crew for a contractor you're going to need manning that one reel versus a micro cable reel, right? So it's less weight. You can have more people, more crews at multiple locations, jetting and placing more fiber than the standard traditional way. So at this point, I think it's a good time to introduce Tim Lowry to us. He's with AFL. And I'm going to pass the baton over to him and let him kind of talk a little bit more on what micro cable is and what it entails, and talk about AFL a little bit.
Yeah, thank you, David. Appreciate it. I'm just going to have you click on these then so we can move through them. And that way you're keeping control. So we have been putting in microfiber, partnered with Dura-Line for over 10 years. We've done just in the area that I'm responsible for, our initial project was a 300-mile and then a 700-mile project. It allows us to gain multiple pathways, as David has said, but it also keeps that OD size down. We have a couple of different areas of size ranging from 6.3 millimeters up to 12.6 and a little over, fitting into multiple future path ducts. Go ahead, David. So the cable, we have a GR20 compliant version of it, which is our LMHD. We will touch on that later. The current product that we've used the most of is a 300-pound load rating. It can be jetted or it can be pulled. Just if you are going to pull it, realize that it does have some less than standard pulling tensions. We're used to seeing 600 pounds. There are string binders once you get up into the higher fiber counts. So you'll have your tubes, as you can see, the 12 and 1 and with the fillers, and then there will be string binders to differentiate your different bundles with inside each tube. Go ahead. So what we've done also, and this has been a big step forward, is we've actually been able to move to higher fiber counts and smaller ODs. By doing this, we have introduced the 200 micron fiber. And just to give you an idea, the size on a 144 that we've been speaking about in a traditional 250 micron fiber version would be 7.9 millimeters. The size for a 288 micron version, or 288 fiber with 200 micron, is 8.1 millimeters. This would allow us to put this cable in the same duct, the 12-710 that David referenced earlier, or the 1410. We can actually get that into and jet down a 10 millimeter ID. So this gives us a lot of flexibility, reducing the overall diameter, making it easier to bring those that future path into certain locations and break it out with smaller splice closures and other materials. So it does save some time and effort. From a splicing standpoint, the procedures are exactly the same with 200 micron as with 250 micron. What we also have introduced just recently was a heavy duty version. So this would be a GR20 compliant. We have our 600-pound load rating. The size goes up, but it also allows us to pull it in between areas. We can lash this cable. And then obviously what we can do is put it down the future path and jet it for the efficiencies that we can get, longer distances than pulling, faster installation times. And then obviously the future proofing of the duct bank as well. So this has been a relatively new product. We also have some different variations on the jackets that we will touch on as well, and a little later with a low smoke, zero halogen jackets on this as well.
Hey, Tim, we have a couple of questions for you.
Okay.
In the current fiber cable environment, how do microcable lead times compare to standard cable?
Oh, hit with the hard questions first.
I know.
Right now, the micro cable lead times from AFL's perspective are running at about the 12 to 14 week lead time. We had transitioned the line into a different factory to keep our lead times down. Comparable outside plant standard cable, I have seen run the gamut from the 10 week to 28 week lead time, depending on different manufacturers out there.
All right. And then one more question for you. How does microfiber compare to traditional in relation to heat and cold differentials?
Very good question. The microfibers are standards compliant, so they react the same way. The advantage that we see is in the future path ducts, it reduces the amount of condensation or water, and David can touch on that, that could penetrate the cable. So it actually has a little bit better advantage that we're not seeing the expansion and contraction due to freezing as much, because that pathway stays more dry than a traditional 1.25 or 2 inch inner duct. As far as, any other water, we've had the cables installed, like I said, for 10 years here in the Northern Illinois area with no negative feedback from, heat and or cold.
Great, thank you. And then we do have another question back to David. David, what are your recommendations if someone wants to place a micro duct inside of an existing duct that has fiber cable in it? And I do believe, Priscilla, this is covered later in the presentation, but David can give you a brief answer now.
Yeah, that's an awesome question, because it leads us into the later part of this discussion. So that answer is going to be 100% answered here shortly. And it's an application that we have that we can talk about. We will talk about that shortly. So good question. Let's put a pin in that one, and it'll be answered here in a little bit. The one thing that I do want to cover, since it's a good time with microfiber, it's always important for customers to understand that when you're building a network and you're deciding to use this technology, we really want to narrow down what fiber count we want and what fiber we're going to be using. And once we've established that, that's where we build the duct around it. So that's super important for us to understand that. We don't want to just pick, hey, I want to do a 1410, because that might limit you. That might say, hey, you're only going to get up to 288, with AFL, but you're not going to be able to get any more than that. So we got to know what fiber count you have and what you want, what you're desiring to have in your network. And then we kind of build the duct and the duct size around that. And a question people are probably thinking of that maybe not asked yet is what's the fill ratio? What's the fill ratio for a fiber per microduct? And Duraline's recommendations on that is 50 to 75% fill ratio. There are customers that have gone to the 80% fill ratio, but our recommendations for the best jetting distances, the best speeds, and really the best performance is within that bread and butter 50 to 75% fill ratio. So I'm going to take an easy calculation here. And I'm going to go with a 1410 microduct, which is the ID is 10 millimeters. So that fiber cable would have to be 5 millimeters to 7.5 millimeters. That way, you're going to be in the best situation for you to have success in jetting and blowing that micro cable into the pathway. So just remember, 50 to 75% fill ratio. And to add on to what Tim was talking about, less condensation, less water. because we're filling those ducts up pretty much to almost max capacity, there's not much volume of water that even gets in there. So even if water were to get into that microduct, and freeze, by all means, it's not thick enough as to where if you have a 2-inch conduit with a lot of void space, and that ice will expand and possibly damage that existing fiber. It doesn't happen at all with a microduct, just because of the fill ratio that you're doing with that.
David, how does Dura-Line define the fill ratio? Do they use diameter or diameter squared?
Great question. So the way that we do it is, it's just simple diameters, right? So no diameter squared. How they calculate that is you're going to take the OD of the fiber, and then you're going to divide that by the ID of the duct, and then times it by 100 to get your percentage. So that's how we define and calculate the fill ratio. Good question. So on to the next one. Next section here. What's great about this section is really nothing changes with the technology, right? You went from 1.25 inch, 2 inch. Now we're going to microducts and future path. Then you've got micro cables. You went from standard cables to micro cables with closures, boxes, and terminals. Really nothing has to change, but it is important to talk about it, discuss it. As we'll learn later with jetting, you can eliminate handholds, space them out farther. But what's great is you keep the same standard size of access point or box, and you can have more slack loop. As you see here, you can be neater with your slack loop. You can have more slack loop. It's a lot easier to work with the smaller ID of the OD of the fiber. And it really allows you to really kind of enjoy the micro technology solution with the space factor, the neatness that you can have inside your access points where you're putting slack loop. On the right here, you see a pedestal. Most of the time customers are putting 1.25 inch or 3/4 inch, maybe a 1/2 inch conduit in there. It takes up space. It's hard to bend those conduits up into a pedestal, or using future path, it makes it even that easier. So a lot of advantages, a lot of features and benefits with using the existing splice enclosures. And these are the guys that are players with Millennium. And this kind of just gives you some names to kind of pinpoint on. But the most important part about the micro technology solution is nothing really has to change. And I know AFL's got their new products with the Apex enclosures, which we can have follow-up discussions on that stuff. But lots of great things that are happening in this industry with new technology.
We have another quick question. What are the issues and also your recommendations for splicing traditional fiber to microfiber?
That's a good question. So if it's within one of these enclosures or in any handhold, manhole, the splicing of it is exactly the same. It's a 250 or a 200 micron based glass. You're going to strip that down to 125, just like you normally would. And then you can do any of your splicing, your butt splicing and anything there. So there's nothing special that has to be done inside your splice trays. The caveat to that would be is if you're going to ribbonize the microfiber, just make sure that you have the appropriate chucks or fiber holders within your ribbon splicer to handle either the 200 or the 250 micron fiber.
Thanks, Tim.
So now we're going to kind of move into the next part of the microtechnology solution and the components, right? Which is placing equipment, couplers and tools and so forth. And this is a real fun part about this solution because this is where you really see the massive advantages of this technology with the tools and the placing equipment that we have. And, the partner that works with Millennium here is GMP. So I'll take some time and introduce Frank Zaccone here. He's the representative for GMP, and he's going to kind of go through some micro jetting machines and the advantages and what they entail and what they incorporate here.
Well, thanks, David. Appreciate that. And good morning, everyone. Yes, for GMP, for those of you who don't know who GMP is, we are a manufacturer out here on the East Coast, and we make all types of equipment for aerial placement, pulling, and of course, jetting. Many of you may know us by our cable lashers. We're most famously known for lashers and we've been around for 85 years. But anyhow, yeah, we are a partner with Millennium as well as Doorline. We work very closely with them and also all the cable manufacturers, but very closely with AFL as well. And I'll be happy to get into my equipment. We have equipment that goes from the smallest fiber to the biggest fiber. Right now, this is becoming very popular with us, this Airstream, because the last few years we've been seeing more and more of the micro. Conventional fiber was very popular for the past, so many years, but it seems like, and we got into this early on, actually. We had these machines around probably for the past 10 to 12 years, but it just seems like in the last couple of years, we started to see a real bump in sales for this type of equipment. So, which obviously tells us there's more and more micro fiber and duct going into the ground. And GMP is a solution for this. We are the last part of the solution, as you can see. They get into the duct and then the fiber, and then once everybody gets their material, then they come to us and they basically ask us, how do we get this in? So that's where GMP comes in. The Airstream, it is belt driven. It goes from 2 millimeter, it goes up to 11 millimeter on a fiber, and with the duct, you can go up to 18 millimeter on this. Okay, so it's a popular machine for us. We do sell quite a bit of them. Occasionally, we also sell this in pneumatic form. Right now, this is electric. It does have an electric power pack that plugs into a generator. But if you want pneumatic, which some of our customers do prefer, we do have a machine that you could use that pneumatically. There's another machine that we have that's coming out shortly. I don't have a picture of it. In fact, I just got a call from it this morning. But it's a Hurricane. It's very similar to the Airstream, but the capacity is a little bit greater on that. With this Airstream, this goes up to 11 millimeter on a fiber and 18 millimeter on a duct. But with this new Hurricane, with that, you'll be able to go up to, on a fiber, it's going to go, I believe, up to 18 millimeter. I'm sorry, 16 millimeter on a fiber, and it's going to go up to 22 millimeter on a duct. So with that, you'll have greater capacity. Again, that's Hurricane. It's coming out shortly, and you'll probably see some information on it real soon, especially you, Jamie, at Millennium, to put the word out. Another thing about the Airstream, you can also do the flat drop. Flat drop seems to be pretty popular in many parts of the country, and we do sell this Airstream for flat drop, but we also sell another machine for the flat drop that's very similar, which is our Whisper. The Whisper goes from, I believe it's 4 millimeter, and it'll go up to 8 millimeter on fiber, and you can go up to, I believe it's 16 millimeter on a duct. However, and you can also do you can do the flat drop with it as well. That's a drill-driven unit. It's that unit right down on the right, the bottom right, and that's what we call our Whisper. That's ideal for runs for fiber to the home, where they're going maybe 1,000, 2,000 feet. And it's a pretty small unit. The unit, the installer may have it in his truck or whatever, just pull it out for those short runs. And this is ideal for that. So it's belt driven. Well, actually, this is roller driven. You've got a rubber roller there, but then it's air assisted. So you can plug a compressor into it. And if your distances are longer, then it is air assisted. So you can use that for air as well. Then we've got this Jetstream, which came out a couple of years ago, and that's been a good item for us also. We like to refer to it as our hybrid unit, which this unit you could use for both conventional fiber as well as micro. You can go down to, I believe it's 4 millimeter on the micro, and you can go up to roughly about 0.8 inches on a conventional fiber. Plus you can get it into micro ducts as well as up to 1.5 inches on a regular conventional duct, inner duct. Now I did ask Jamie to put in this micro compressor also, only because I feel it's a very important piece of the whole process of jetting. As you know, air assist, I mean, the thing that's going to give you the distance is the PSI, is that pressure. Okay, you can use a toe-long compressor, one of the Ingersoll Rands. You could use the 185s or the 375s, but on a 185 maximum, you may get maybe 120, 125 PSI. And that's on a good, on a newer unit. Usually, a lot of the ones I see in the field, you may get 100 PSI, maybe a little bit less on them. And even on a 375, maximum is usually around 150 to 160 PSI. Well, this particular unit gives you up to 220 PSI. Again, that's ideal for distance. I've personally, with an Airstream, I've been able to get 10,000 feet by using this unit. Okay, which I don't know, if you had a bigger unit, you may not be able to get as far. The other advantage of this microcompressor is that it comes with an air cooler and water separator, which is very important, especially when they're working, in the summer months where the air is very hot. So rather than blowing in hot, moist air, with this, you get dry, cool air that's going in that duct. And again, that affects performance, and you can go much further with that micro using something like this. As you can see, it's fairly small. It's somewhat compact. You can just, you can roll it up onto a pickup truck, and you don't need to tow it as you do with some of those bigger compressors.
Hey, Frank, we have a quick question. How far
Okay.
can you install microfiber with the Airstream?
Well, again, it's a tough question only because there's a lot of factors involved. It depends on the air, on the compressor that you use, because the air is really what gives you the distance, plus the condition of the duct. If you have a lot of bends do add resistance. So every time you add resistance, it affects the performance. Now, as I said, I've been on jobs. I was just on a job, I guess, last February, where I was able to get 12,000 feet with an Airstream. But again, conditions were pretty good. The run was fairly straight. We did use our Airstream, which gave us maximum air pressure. And, but again, there's a lot of factors involved. The machine works great, but it's all these other factors that affect how the machine works. So it's a difficult question to answer, to be quite honest. Okay, now here's some other slides that we have here, and these are just some action shots here. The one in the top right, that is our Airstream. Typically, that customer is using it. He's just setting it up on top of a box, and he is feeding air with it. It's not really showing much because, again, it's not running, but again, it's just showing the Airstream there in use. The one on the top right, I believe that's Joe Kyle in that picture, who does work. He's your resident expert, I guess, there at Millennium. But that's using our Jetstream right there, teaching a couple installers how to use it. And the bottom two photos there are our the Tornadoes, okay, in use. The Tornado, by the way, you can do some micro with that. That'll go down to 6 millimeter, and it'll do your largest capacity fiber up to 1.34. So that's really pretty much our full range machine. But if you go smaller on a fiber, that's not the right machine for you. Okay, but it's a great unit, and a lot of the customers do have them. They already have this Tornado, and if they're not going, if their micro is 6 millimeter or above, they can convert this for the micro.
And Frank, can you please remind us, how long did it take to put in 12,000 feet using one of the GMP machines?
I think, well, the day that we were there, I think I was going at around 250 feet a minute, maybe a little bit more. You spend more time in the setup than the actual performance. The actual performance may have taken, I don't know, 30 to 45 minutes, maybe a little bit longer. I don't know exactly, but again, just to set up, getting there, that's what really takes more time than anything. But once you're settled and you get going and the compressor is hooked up, then you just keep going. If you don't have any issues, if your ducts are lined up right, I mean, if your couplers are on nice and tight, that thing's going to keep going for you. So that machine does go, I think we say it goes up to 280 feet a minute. And if that duct is nice and if it's dry and it's placed correctly and you have good air, it's going to take no time to put that in. Within an hour, I would say, or less.
Great, thank you so much.
Mm-hmm. Okay, and this is something I had asked Jamie to put into this presentation. This is our full family of machines that we offer. And again, we've got machines that go from the smallest fiber, we call our microfiber. That is more for that EABF spaghetti type, noodle type fiber. And we do have that machine. It is standard with a couple of the bigger bell companies already. The Gentle Air, that's a machine that we have. It's very similar to our Whisper, but that's more for smaller fiber. And it's hard to read there, but I think we go from 1 to 3 millimeter. So it's for very small fiber and also a very small duct from 4 to 7 millimeter on a duct. Okay, as well as this Accelerator 2, that's for the very tiny, maybe glass blown fiber stuff that's very small. In fact, that's below 1 millimeter. I think it's 0.8 is where it goes down to. So there's a small range there from 0.8 to, I believe it's 3 millimeter. Okay. These next few machines are really the machines that we are focusing on in this presentation, which was the Whisper. Then we have a flat drop Whisper, although you can convert the Whisper for flat drop. There is a kit that you can convert, so you don't necessarily need two separate machines. The Airstream, we have, it shows the pneumatic. Pneumatic right now is kind of a special because we don't get too many calls for pneumatic, but it's available if the customer wants it. In fact, I think we just sold one not so long ago. If you prefer pneumatic, that is available. Then we have the Airstream. And the one that says coming soon, that's the Hurricane that I just spoke about, which is, it looks a little bit different than the Airstream. It's similar. The lower range is similar, but it goes a little bit bigger. As I said, on this one, it goes up, we say it goes up to 16 millimeter on a fiber and 22 millimeter on a duct. Okay, then the Jetstream, that's the hybrid machine I mentioned earlier that does both the micro as well as the conventional. Goes up to 0.8 of an inch of fiber. And then of course we got our Tornado. That's our workhorse. So, okay, now this, again, I think we're really, David put this in here, but I think the point he's trying to make is that in blowing microfiber, speed, of course, is a factor. You know, you can blow it pretty quickly there, several hundred feet a minute. I know that on one of his slides, he did say 300 to 500 feet a minute. 500 feet is, I mean, that's fast. You know, certainly I don't recommend you going that fast because if you have a problem, boy, that's a, you know, that could create some issues there. But, you know, I mean, we basically go up to 300 feet. We try not to go any further than that, any faster than that. So basically that's just showing the process that you can go pretty fast with those machines.
Yeah, so I have a video here, and really, yeah, like you mentioned, this video's here to show you the speed factor, but maybe we'll have to share this with you as a follow-up due to time constraints here. We've still got quite a bit of stuff we want to cover, but yeah, as Frank mentioned, your typical speeds out in the field are going to be somewhere between 200 to 300 feet a minute, and if you're doing a mile, that's 15 to 20 minutes in for a mile's worth of placing fiber, which is very awesome. It's something that allows you to put multiple miles in a day in a short amount of time and a lot faster speeds. So we can show this video to you on a follow-up if that's something that you guys want to see. We'll kind of pass on with that one for now. So what's good about this, and also not only the speed factor, but it's the space factor. What's great about this technology is you can space out your handholds. You can save money in your cost to place a handhole, right? The traditional numbers, they can be lower or less, but usually a good number is about $1,000 per box that you're placing for an access point. So the old traditional way of doing a fiber build is maybe every 500, 700 feet. If you're in city limits, that's definitely the case. Really what we educate our customers, also the engineers, is if you're going to use this technology, you can have them spaced out farther if you're not constrained to how you're installing it. So the old technology of pulling, right? You're constrained to go on a certain distance before you have to have another access point, where really you put a box where you might go left or right or change directions, or maybe you're going to add something down the road. That's where you'll want to put an access point, but you can eliminate a lot of those with this technology, which does save you time and money in the grand scheme of things. Going into a question that may come up about, well, how do you splice future path? Going back to the pathway, it's as simple as our couplers. We have end caps to cap off the microducts if we're not putting a fiber in there to keep dirt and water out. And the couplers, the straight through couplers, these couplers are like shark bites. So anybody who's done plumbing in their home, they have the metal teeth that clamp onto the HDPE, and then you can release them by simply clicking on the. So this is what a coupler looks like here, and you just push on the side of it to release those metal teeth, and that will release off the duct. But it's as simple as pushing this guy right on, and that easy, right? It'll come right off. It doesn't come off. This holds on to 250 to 300 PSI of air pressure. It's airtight, watertight. So nothing's going to go through that as long as it's a good cut, clean cut. And that goes into why you have cutters here. So when you're cutting a microduct, you want to make sure you have a straight cutter, so you can fit that straight coupler flush right into the inside of that. That longitudinal slitter there on the bottom right corner, that's another tool. If rip cords aren't functioning the way that you need them to, that tool allows you to cut the oversheath off, exposing the microducts. What's great about that cutter, it's specified for this technology. You don't want to use a typical, duct cutter, because they'll cut the microducts inside. Where this has a black tip on it, it hides the blade so it doesn't cut the microducts, and it keeps the microducts internally safe from getting cut. Splice kits is something that we do. So if you have the end of a reel and you want to put that direct bury into the ground, you're going to connect your reels together, put your couplers on there. All of it's direct bury though. Just keep in mind, our future path is direct bury. So, taking off that oversheath, maybe doing a banana flay where you're peeling back the oversheath, and then you couple your microducts together, connect your gauge wire, put the banana flay of the oversheath back over, and then tape it up. That's just as good as a splice kit, because all of it's HDPE, right? So when you expose those inner microducts, it's the same thing as a standard conduit with 1.25 inch and so forth. So this is kind of where we're going to talk about that question that was answered earlier. We're going to go into a little bit of applications, why and where we use this product, and how it can help your network. And everything that we talk about here, we might be breezing through it a little quick, but it's really just to kind of tease you. It allows you to learn what this technology is, and where these applications can be used. And we could maybe even do a follow-up webinar later on specific applications, overrides, or other things that we might talk about later, to go in a little bit more depth of how you do them and how you work them into your networks. But we're going to start with the override. And really the override can be used today with pretty much every single customer that's known to man in this industry. We all have 1.25 inch conduit in the ground or 2-inch conduit, and we've got fiber that's existing into that network. And the first thing we think of when I say, hey, I need new bandwidth, I need more space, they maybe possibly try a really high risk but low reward situation, and they try and pull a fiber over top. That's not necessarily the best idea. It does kind of work. You run into more issues really. Your distances, the fiber tangling, possibly damaging your really expensive fiber you just bought. Like I said, high risk, very low reward. But with this solution here, with doing an override, it's very low risk, but high reward. And the reason it's low risk is mainly the cost, right? The cost of microducts to place inside, get them installed. And if it were to tangle, if it were to fail or any of that, it's low risk, right? It's 10 cents a foot for a microduct. And the reward though, when it does, and it does work often, and the only issues you really run into with an override is if that existing pathway is not in good shape. Maybe we've got a kink in the pathway, maybe a coupler wasn't put on quite right, but all that stuff can be essentially dug up and fixed to continue on through that pathway, right? Those are the errors that you kind of run into. But what this override solution looks like is we place microducts over top of that existing fiber that's in your network. That picture here kind of shows you what it looks like. This is another kind of cut sheet of what an override would entail by placing microducts, protective pathways, permanent pathways over that. And right, so the way that this is installed is we use a jetting machine. So going back to GMP and their tornadoes, we'll show you some photos here in a second. We'll even show you a video of this. But how we do it is we jet these microducts over top, and we're using air to help float those microducts up and around over top of that existing fiber. And that is what makes it so it doesn't get tangled. Whereas if you're pulling, you're wherever that cable's going and wherever it directs you, depending on how you're pulling the fiber in. You can see here on the bottom two photos, there's a Y block, and we'll talk about what that Y block does here in a second. but really what it does is it separates that existing fiber cable and then creating a pathway for those microducts to go into the existing duct, allowing us to hold air pressure and push it through the existing conduit, so we can float those microducts over top the existing fiber. So here's a video. We're going to see if this video works here. Just holler at me if it's not coming through, and we'll try this one out here. So I'll ask the group here if anybody wants to ask questions, maybe toss one in the Q&A. Any questions you may have had. I could breeze through the questions that I usually get, but is there any questions on what you saw there with this particular video? You know, we've got our microducts here. They're on a reel trailer, and this what's great about this is we fill this whole reel of microduct up with air pressure, because that machine, the jetting machine, the Tornado, is actually pushing down onto those ducts. So we want to have them nice and rigid, kind of like rodders into their existing infrastructure. If you've ever done rodding, these microducts essentially become rodders, and really, you know, rigid and robust. As it's going through the machine here, you can go, as we go in here, those tracks are pushing it. You've got your air pressure machine here, right there. So this is where air is going into the existing conduit and pushing air forward through the existing pathway, that 2-inch conduit. And then as you saw, as it goes down into the handhole here, we've got that Y block. And that Y block is essential. It's one of the most important pieces of doing an override. That's what holds the air, and that's what makes the air not come backwards, but force it to go through the existing pathway, allowing those microducts to float and be placed around that existing fiber. Any questions?
I just wanted to jump in for a second, Dave, just to let them know that with our machine, our Tornado, you do have the capability of blowing 4 of those microducts in at one time. Okay, it's just a matter of getting the right collets and seals, but our machine is capable of blowing in those microducts. We do have the pressurization kits for those also.
Yes.
Those ducts, they get pressurized, and once they're pressurized, it's basically like blowing in 4 cables is basically what you're doing. So the capability is there. Plus, we also do manufacture the Y box for the junction box. That is something you get from GMP.
Perfect. What was the question that we had?
There was this question if you could get the Y blocks from GMP, and yes, you can. But we do have another question of how do you pressurize the microducts on the reel?
That's a great question. So these are the things that Frank said that they sell, right? It's a matter of hooking up your air compressor. It's a valve. You're going to use it's kind of a handmade situation where we've got our couplers that then go onto a pipe that go into our created, valve, where it's a turn off and turn on valve. And then that allows you to put the air into the whole microduct, reel of microduct. And on the front end of that reel, the initial portion of microduct that we push in, we've got a bullet screwed into there. So it's like a pulling eye. You're going to screw a little bullet into that. That's what will hold and cap off the microduct. And then you fill up that whole reel of air to about 100 PSI. Is the points are 90 to 110 PSI. Once you stop hearing the air, you'll hear the air go through the whole reel. Once you stop hearing that air, at that point, it's full. And then you're going to turn off the air. You're going to uncouple that valve. The valve will stay on there on the reel to hold the air in. And then you wait like five minutes and make sure that air pressure is still holding between the 90 to 100 PSI. So that's how you use it. It's all tools. It's getting those tools from GMP and making sure that we have the right setup. Great question. And I think the question is that we asked earlier was, how do I know how many microducts I can put in, right? Well, we have a calculator with Duraline. We haven't quite distributed that out to customers yet. At some point in time, we want to have it on our website to where you can input the main factors. But really what needs to be shared with Duraline and how we calculate that is what's the existing conduit? Is it 1.25 inches? And what is the wall thickness? So we can know the ID that we have inside that duct. And then we need to know the actual OD of fiber that's in the existing conduit. Once we do that, we have a calculator that within about 55%, we put in 2 or 3, and we calculate up to 55% overall fill ratio of that duct. And that's what kind of helps us calculate that. It's not a calculator we've promoted out to customers, but we support you, and we just ask that we find out what the ID is and the OD of the existing fiber, and then we can tell you exactly how many microducts you can place inside. So kind of going to override benefits. And once again, this is kind of a teaser situation, right? I'm assuming there's a lot of you that have maybe more questions and want to dive deeper into this. Well, we can provide that to you, and we can definitely go in a little bit more depth of what this entails and how we can maybe work this into your network that you may have. But the huge benefits here is very low risk, right? Cheap material. If you're not spending, $3 to $4 to pull in an existing a brand new fiber over top of your network that could get damaged, where you've got a 10 to 15 cents a foot microduct that you're placing inside. But once it's in, and when it is in, you actually hook up your microducts with couplers and multiple access points, and you're jetting your fiber from point to point. It's a dedicated pathway. It's a permanent pathway. Allows you to install in long distances, have slack loop at each access point. It's really it's a great solution for our customers that are looking to maybe not have to dig again and build, but they want to enhance their network that they have. So here's another way of looking at an override. We call this a future path override. This really only is going to come into play if you have a larger conduit system in the ground, maybe a 3-inch and up, 3-inch, 4-inch, 6-inch. If it's in the system and you placed it there for added capacity down the road, and you got an existing fiber, well, there's the same type of situation where we could calculate, how many future path materials. Maybe it's a couple 2 ways, maybe it's a couple 3 or 4 ways. If it's a big enough pathway, it might be a couple 7 ways that we can put inside of that and pull into that infrastructure. Existing underground. This is kind of a sister solution to overrides, where customers may have put in multiple 1.25 inches in the ground. They didn't use them all. They have them empty. So what we recommend is utilize that space to your max capacity. Let's put as many microducts in there now, so we don't do an override later and have to pay the labor and the cost and the fees to do that. We say put as many pathways in now, and then you don't have to use all of them. You can use 1 or 2 for now for your infrastructure, but utilize that space. Put in as many microducts as possible. This is just kind of a screenshot of 3 different sizes of microducts that you can use within 3 different sizes of conduit systems that are out there in the network quite often: 1.25 inches, 1.5 inches, and 2-inch. Obviously, the bigger size microduct you get, the more density of fiber you're going to be able to place inside. But as we learned with the 12-7-10, AFL can put at least a 144 in each one of those 12-7-10s. Yeah, there's the opportunity with the 200 micron to do 288, but at least you're getting 144s into those 12-7-10s.
David, real quick, we have a couple of questions. If you're installing multiple single microduct into existing duct that has the fiber in it, how do you keep it from getting tangled, as fiber doesn't always lay flat?
Yeah, great question. So, over time, that fiber can relax as it's been in the network and so forth. There isn't any way to prevent it. It is more preventable by the solution that we do with pushing air through there. That air helps float those and disconnect really those ducts as they're touching, it really helps them float around that cable. And, you know, HDPE has a natural less friction on it. There's just the way the material is made. It does kind of glide past that, where another fiber cable does. It's the way that the oversheath's made, doesn't have as much HDPE resin materials as our duct does. So it's got less friction over it. It does glide past that fiber a lot easier. And really it's the method. The method is what allows it to avoid tangling as much as possible. But the answer to that is you can't completely avoid it. And there are times where those microducts just might stop. The great thing about that is our microducts they have footage markers on them. So when that does happen, we know how far we've gone in, we can walk off, and we end up having to dig up that particular location to find out what happened. Maybe it's a conduit, existing conduit system. Maybe it did get tangled. But that is something that that's how we work through it. But more often than not, it is successful. And you
All
don't
right.
tangling.
And the second question is, what have you found to be the most effective method of blowing through handholds and then pulling slack back into them?
Yeah, great question. So the way that we do it, the way that we suggest doing it, is it's really how you set up your future path. So it just depends on the contractor, how they have those future path bundles, or how they have, if we're talking about the override situation, what we do is we say, hey, have those microducts really connect straight across the handhole to each other with a coupler. And then what's the best way to do it is you have your jetting machine on the left side, and you're going to jet through 3 access points where you've got that microduct being placed straight through the handhole, if it's possible. With an override, it is. So you're going to couple that together, make it go straight across it, straight to the other side. You're going to blow through 3 access points. And then on that 3rd access point, far away from the jetting machine, you're going to jet in an additional 100 feet of slack loop. After you've done that, you turn the air off, you stop the machine, and then you work your way back to access point 2, and you simply uncouple that microduct, and then you turn the air back on, make the fiber float, and then you start jetting in your 100 feet of slack loop at access point 2. Then you have your 100 feet of slack there. Then you stop the machine, stop the air, go back to access point 1, uncouple that coupler, and do the same thing. Float the air, put the air on, float the fiber, and put in another 100 feet of slack loop. So that's the most efficient way, and that is the best way to install slack loop with this technology, where typically you're figure 8ing with the standard traditional way, where this, it's as simple as blow as far as you possibly can, and then work your way backwards towards the machine, uncoupling that microduct from in the access point with the coupler, and then jetting in the slack loop.
All right, and we are at the 1 hour mark. I think we're a little bit over. So if anybody has to go, this presentation will be available for download. I just wanted to let you guys know that. We will send it out to you. And yeah, I can't wait for the rest of it. Thank you.
Thanks, and we apologize that we're running over, but those of you who can stick on to continue on, that's great. We appreciate your time. If not, check back on the recording. So installation methods, really the great thing about this, and the great thing about this technology is it's HDPE, it's conduit, it comes on reels, it's flexible, it's the same thing as standard conduit. So you're able to open trench this product, you're able to directionally bore it, HDD, you're able to plow it as well. It's the same type of standards. You just need to make sure your plow chute has the right bend radius. You just have to make sure you're doing the same thing as what you would do with the 2-inch conduit and so forth. But this product actually tends to be a little bit more robust, has more strength to it. Here's some more photos of in-field installations with FuturePath. As well as this slide here, and what customers have done with that slack loop and couplers and connecting from point to point. There's a lot of benefits with this, right? So a typical 2-inch conduit, that's a 7-way 1814 future path configuration. That's got the OD a little bit over 2 inches. That product has, you know, about a couple hundred more pounds worth of pull strength. So this product tends to have a little bit more pull strength to it, but that does not mean it's not flexible. So this stuff is flexible. It is, you can maneuver it and you can work with it just as easy as standard conduit. So here's another photo of just kind of the differences between standard conduit, really the kind of mesh you work with multiple pathways, how much men you've got there, a really high risk situation with all of the ducts being placed into a rail system there, where it may be just as simple as adding some future path for some pathways there. So one feature that that Dura-Line came in, as you guys know, Dura-Line's always doing our best to adapt to the industry, to the network, to really evolutionize the pathway. And we came out with a product in 2018 where we wanted to incorporate, for those customers that are still sticking with armored fiber cables, maybe they have high density fiber cables that you can't put that density inside of our microducts, and they want to stick with the traditional way of doing stuff. But they want to have the added benefits of placing the stuff in under one oversheath. We came out with a product called Jumbo Future Path. Our Jumbo Future Path is a mix of standard conduits, so all 1.25 inches and 1.5 inch products, and we're putting those inside of an oversheath. So terminology, when you hear the word Jumbo Future Path, that's standard conduit inside of an oversheath with a gauge wire, all on one reel, making the staging of installing your pathways a little easier for you out in the field. We also enhanced that. We enhanced that, and we went with a hybrid future path configuration. This hybrid future path configuration has been a huge seller for us in the last 2 years. Because there's customers that want high density, they want to use armored fiber, but they want to start incorporating maybe for small cell sites or maybe for drops. You know, they can use microducts and so forth. So the hybrid future path consists of standard conduit and then microducts. Or we have hybrid future path that's 2 different sizes of microducts, right? So it's really just emphasizing 2 different sizes of pathways bundled in an oversheath. What's good about our solution that we have here with that 6-way hybrid future path? I've got one here with a green oversheath for a customer in Wisconsin. But what's great about this product here is the standard one is an overall OD of a little bit less than 4 inches. It's like 3.98. But we have one where it's a SIDR, which makes the OD of that 1.25 inches a little smaller. And the overall OD of that is small enough to where we can fit that into an existing 4-inch conduit. So if there's 4-inch PVC pipe in the ground, a lot of customers are using Maxell, the fabric liner, which isn't a permanent pathway. They can tangle, and in that method, you're still pulling in your fiber, so you're having to cut at certain spots, having to do a lot of figure eighting. Where this, as you can see, it's a permanent pathway. You pull this into the existing 4-inch conduit, you got 6 pathways. And you can couple those together at the access points or the manholes or the handholes, and then jet right through those locations and then work your way backwards for slack loop. So it's an enhanced solution for our customers. And what's an eye opener for everyone is really this, the density, right? The 1728, you can put a larger fiber cable in there, but the more commonly used one inside the 1.25 inches is a 1728. The density is just unreal, right? 3 times 1728, and then in each of the 1814 microducts, you can put a 432 count microfiber. That's a total of 6,480 fibers. So the density factor is just incredible. Another one that we have is we do 3.5 with 3 22/16s, and you get even more density here, where the sky's the limit with this particular product. You can incorporate traditional stuff with micro technology, And this has been a great product for our customers in the last 2 years since we started making it. Here's some other configurations, but before I kind of go into that, it's also important to understand the main reason we made this hybrid future path is really to replace 4-inch conduit. So people who are placing 4-inch in the ground, they're paying their contractors to place that 4-inch, and they're using it as a place saver. Because later they're going to put multiple fibers in there, or they're going to come back in and pull 3 1/4 or 4-inch conduits inside of it, which is a 2-step install, a 2-step process that you're paying the contractors twice to come out and add capacity, where we could pay the contractor once, install this into the ground once, and I've got 6 pathways, more pathways than you'll ever get with a 4-inch. So really this product does replace it. It is kind of a no-brainer. The cost of this is less than a 4-inch and Maxell and a 4-inch and inner ducts that you're putting inside. So you're not only saving money on material, but you're also saving money on labor as well. So here's some more photos of our hybrid future path which is just multiple microduct sizes. We have a 15-way here on the left. This product is huge up in Canada. They're using the larger microducts in the side in the inside for their main backbone, and then they're using the microducts on the outside for their drops for the fiber to the home locations. The one on the right's an interesting one. We used that one in New York. As you can see, it's got a clear oversheath. For those customers who are using this as a fiber to the home drop situation, we have the option of doing a UV rated clear oversheath. So when you dig this up and you have to access a specific duct to drop off to a home, that clear oversheath is it's incredible to have, because you can locate exactly where that color is, and you can cut exactly where that microduct's at, saving you time and installation. So one important part about microtechnology is to understand where you're saving money. A lot of customers will say, I've priced this out. I've had you guys cost it out, and there's just no way I'm going to use FuturePath because of how much, more expensive it is. Well, it's not about the material. It's about the overall installation. It's about how quickly I can blow fiber. Going from pulling to jetting, you're going to save money in jetting. Going from using FuturePath from traditional, spacing out your hand holes, $1,000. Remember that $1,000 per hand hole you place. That's the labor cost, and that's also the cost of the hand hole, what it costs to install that. It's important for us as customers to understand it's the big picture. It's not just about, oh, I'm spending maybe $1, or as you see here, a cost breakdown with FuturePath. I'm paying a little bit more expensive cost for a FuturePath, and it's just not worth it for me. We really have to educate our customers and understand the big picture, and this is what this does. I'm comparing an 1 1/4 conduit, which is the most competitive product out there that everybody kind of goes to, versus a FuturePath containing 1410 microducts. You can see the cost breakdown in material there. An 1 1/4 is 35 cents a foot. Now this is all relative, right? This cost for 1 1/4 has gone up in recent days with the resin increases and so forth, but this is all relative depending on where you're at, what city, if you're in Chicago versus a small town in Kansas. But the cost is all relative. It fluctuates up and down depending on where you're living. But here's a cost breakdown of material, and then you've got your installation cost. So a contractor is going to charge you a minimum of, for an 1 1/4 install, $6 a foot. And once again, people are like, I'm in Chicago. There's no way I'm paying $6 a foot for this. But it's all relative. It depends on where that starts. But usually a contractor is going to charge you $1 extra a foot to place in another 1 1/4. So if you're putting in multiple 1 1/4s, if you're putting in multiple 2-inch conduits, they're going to usually charge you an extra $1 per duct or pathway that you're installing. And the most important part about this is when you get to a certain hole size, above 3-inch, anybody who's familiar with horizontal directional drilling, back reaming becomes a factor. And that's a flat rate of a certain cost, right? Maybe that's $5 a foot, maybe it's $10 a foot, whatever that contractor's charging you. When you get above that hole size where they have to back ream, That's what cost you a lot of money. So if you're placing more than 1.25 inches in the ground, you are not cheaper by buying that versus Future Path. As you can see, this is a 1,000-foot run, and you can see the cost breakdown here of really where you can save money. And so it's important for us to share with our customers, hey, if you're considering installing more than just a single duct, Future Path will save you money. You may even get 2 or 3 more pathways for the same cost, and have added capacity down the road. Here's another cost breakdown. There's 2 more cost breakdowns here, and we can share this with you guys. But this also incorporates fiber. I have it listed in here that the fiber is more expensive for Micro Technology, just to kind of shorten the gap, right? But in reality, fiber cable, a 288 non-armored loose tube versus a 288 microfiber, they're about the same cost. When it first started coming out, they used to be a little bit higher, but they're about the same cost. The turnaround times nowadays, micro cable is a lot less turnaround time than standard fiber too. So this just kind of shows you the jetting installation installs and the cost per foot, and really can show you, how much money you can save if you're not just looking at, the initial pathway cost. Do we have any questions?
Not at the moment, but we do have 15 minutes left. So if you guys have any more last minute questions, please start throwing them in there so we can make sure they get answered.
Yes, please. So this is just comparing, 4 2-inch conduits versus a 7-way Future Path. And really the biggest thing just to understand here is when you install more than one pathway conventionally, it's a smart thing to just consider Future Path. You could save a lot of money, and you could have more density in terms of pathways if you consider using Micro Technology. So aerial, kind of going and diving into the different types of Future Path configurations that we have. This is where we have our aerial Future Path. This is a lashable Future Path, and it works great with GMP and their lash machines that they have. It's all ribbed on the outside to where when you lash onto an existing messenger wire on the poles, this is a product that you would want to install. If the messenger wire is already there, it is UV resistant. You have multiple pathways. And the great thing about this particular product here is the ability to clean up your poles. So you have, power utilities are usually the guys who owns these poles throughout the cities. And they've got multiple carriers begging and asking, hey, can I have rights? Can I have the ability to be at a certain footage and the multiple levels and multiple bucket trucks, and just it cleans up the poles to where, a city might like this, to where, certain carriers have certain colors, and when they need to access it, you bring your Future Path down to your access point into a handhold that's buried in the ground, and then they can access their slack loop and their fiber there that then goes back up the poles and moves on to their next access point. So it's something that does save customers time and money, and it does save costs, right? We had a huge customer in Colorado who did this, and they were on a consistent basis jetting up and down poles, 10,000 feet without having to cut their fiber. So it's a great solution for them. Having a dedicated pathway, to install your fiber is a huge advantage for customers aerially. Here's some photos out in the field of what it looks like, when you're splicing. If you have a splice enclosure up on the pole in the lash wires location, what it looks like bringing the Future Path down a cane and down into a box. And then we also have another aerial Future Path configuration, which is our figure 8. So the messenger wire isn't there, so you use this figure 8 product, and the 1/4 inch galvanized steel, extra high strength steel strand will become your self-supported feature in your messenger wire there. Same concept, you just have the messenger wire included. Indoor campuses.
We do have a quick question, David. How far is the average distance you can jet microfiber?
The average distance, even with bends and turns, so I'll give you an example that we have, right? So this is something you should never run into in the field unless there's just been major miscommunication on how it was installed. But Duraline, when we came out with this product, 15 plus years ago, we have a plant in Clinton, Tennessee, where we manufacture this. And we have a test track there that we've had GMP visit. We've had all of our other jetting machine equipment companies come there. We've had AFL come there, test out their new products. And that track itself is 4,000 total feet. And in each 1,000 feet, there's 19 90s. So 19 times 4, that's 72 plus 90s. And we jet through that 4,000 feet without any issues. And that's something you should really never encounter in a field, having 17 90s in a 1,000-foot span. But that's just to tell you that even with bins, if the product was installed properly and there's no kinks in the duct, with 90s, with the 45-degree bins, and whatnot, you should consistently be able to blow at least a mile's worth of fiber. But once again, it's a hard question to answer, but that just kind of lets you know, we tested AFL's fiber, we tested all the other fiber manufacturers when they came out with new products at that test track, and we're successfully blowing through 4,000 feet in multiple 90s with no issues. So that's just the extreme. But it really is dependent on how it's installed, how much elevation change we've got. It is relative, but this technology with the ribbed in, the super silicord, the micro cable, the light fiber cable, and using air and our machines that we've tested and trialed, you can be very successful with your jetting distances here. And as long as you're staying within the fill ratio of 50 to 75%.
Great. And we have the jetting equipment can be demonstrated. Millennium does offer demos for that, and you can inquire about that later in the presentation. Thank you.
Yes. This presentation's meant to get you teased, right? To tease you about this technology and really have you reach back out to us and ask more detailed questions and allow us to narrow down exactly what you're looking for. And we're here to support you as manufacturers, and Millennium is here to support you in getting you to the right people too. So kind of moving into MDUs, right? Customers that we work with a lot are incorporating their networks, their internet service providers are going into MDUs. And this really is the best product out there for MDU usage. Having a dedicated pathway per tenant, per location, also installation and how you install it, and restoration cost, right? Sometimes MDUs get beat up. Sometimes, sheetrock gets ripped out and fiber gets broken. It takes a lot of time and restoration costs to fish new fiber, repair, splice the fiber that's broken. Where you have dedicated pathway, that pathway one is going to protect it from nails and any of that kind of stuff. But if it does get damaged, you simply cut out the damaged duct, couple a new piece in, and then pull your fiber through that pathway, and you're up and running a lot faster. So this product is great for MDUs. It does provide a lot of benefits for our internet service providers and that are trying to get in and really get to the next generation of people who are starting their lives and possibly starting in MDUs before they start building a home and whatnot. Maybe it's college students and not, but this is that market of MDUs and tenants, multiple tenants in a building is just kind of skyrocketing right now. This is kind of a breakdown of what it looks like in a greenfield, and then a brownfield situation here. You obviously have the walls already up and in place, and how you do that is have a riser protected raceway externally on the building going into the attic space, and then you're going to drop these pathways through the attic space to the specific levels that you want to go to. Already mentioned what the benefits are here, but really it's all about having a dedicated permanent pathway, and also to understand it's a reusable pathway. So when you take fiber out, you can put fiber back in. It's a reusable pathway. You got protection. It's ruggedized. And you also have the ability to add fiber at a later date or increase capacity down the road if you need to. Low smoke, zero halogen. This is kind of where we're going to tap in Tim here in a second. But Tim, AFL and Duraline have a great package for railways and tunnels, and for areas where low smoke, zero halogen is huge. Just to kind of give you an idea, if you don't know what low smoke, zero halogen is, it's a product that when fire happens and it burns, it doesn't emit smoke and it doesn't emit the gases that other materials will do. So it's something that's a requirement for these particular locations. The main standard here is the NFPA 130. And all of our product, our FuturePath, our microducts, they all adhere to these standards. And we've also partnered with, with AFL, and they have a product that goes inside of the microducts as well. And I'll tag in for Tim to talk about this as well.
Yeah, it's a very similar product in design to the other microcore cables that we've talked about. As David said, the key is the NFPA 130 requirements for transit. And that's the big differentiator on this cable. We have existing installs. You're welcome to contact any of us for references on any of these projects, from David to Frank or myself, and also Millennium. Sorry.
Yep. Well, I appreciate it. That's good. If anything, you got to see what these manufacturers are doing and how we're trying to make better products to really help our demand and our customers out in different varieties of situations, really, right?
Yeah.
So
I guess one side note, David, is that went up to 144, released within 30 days or so of us. This summer, you will see a 288 version of that cable as well.
Nice. Once again, improving the abilities, right? I mean, that's what we're trying to do. We're trying to work towards the demand that our customers have. That's incredible. So last aspect here, and once again, this is a teaser. We'll breeze through it. But micro trenching is a huge opportunity for city ofs and places that have restrictions for right-of-way space, for permitting and whatnot. Our Flex FuturePath is a great product to use for micro trenching. This product is used a lot in the warmer climate areas. It's hesitant in the colder climates, but we have a great partner with this, and it's all about how you restore the material, how you're packing it, of making so there's not air or ability for water to get down and cause it to freeze and thaw and cause, elevation changes with the restoration of the asphalt and so forth. But FuturePath is a huge opportunity for these customers that really want to enhance the increase of installation and really how long we're cutting down and closing roads. The professionals that do this a lot with Ditch Witch and with Vermeer, that are doing a lot, they're installing the duct and the fiber and the pathway and restoration and everything. They're doing about a mile a day. And it's as quick as, really a mile a day, and you're cutting it. It's an assembly line where you've got your machine on the top left here that's cutting the saw cut. It's vacuum sucking all the asphalt and the dirt out, getting it prepped for when we place our Flex FuturePath in there. And then immediately after that, we're putting in a product here that we've partnered with a great partner. We can send we did a huge seminar down in Texas a few years ago, and we had everybody come down, and there's a product that we put in here that really helps the restoration process. And as years pass with water and really the weather kind of eroding it and so forth, making it so it lasts kind of the test of time there. So micro trenching is a huge advantage, and we can also talk about that more in detail if anybody is interested in that. But really, it's an opportunity for customers that are interested in it, and we have great products that work with micro trenching. So here's some photos here of what it looks like out in the field, using the Flex FuturePath, peeling off a couple pathways to the left or to the right. And this is kind of where I want to end it, and then we'll ask the last remaining questions. But to wrap up this whole solution, right, there's 4 major points that all of us need to remember with this solution and micro technology in general is, 1, you can use our existing infrastructure. Let's do overrides. Let's fill up to capacity our existing empty conduits with microducts. We can use that existing infrastructure by using microtechnology, and it is very successful by doing that. 2, most present value. City ofs, any city ofs that want to place future path, they own these pathways. They have the ability to sell them, lease them out, make the city money, make the city a more valuable city by having multiple internet service providers come in and use those pathways, eliminating permits by digging once, right? I mean, it's all a perfect solution for city ofs and those particular customers, even customers that, you know, are willing to sell off their pathways to other people too. Total cost of ownership, right? The ability to add fiber down the road. I've got a 4-way in the ground. I'm only using 1 for now, but I got 3 to grow down in the future. I have added capacity. Now I'm just paying $1 a foot to install a fiber instead of paying that $8 to $10 a foot to dig again because I put just a 1.25 inches in the ground. And last but not least, ease of installation. Everything's cheaper, faster, and more efficient with using this technology. And you really have to have the big picture. It's not just comparing micro cable to standard cable. It's not comparing future path to standard duct. It's comparing the whole picture and really seeing the whole thing. So I appreciate it. That's it. Thanks for your time. Thanks for the partnerships with AFL, GMP, and Millennium. I mean, any other questions, let me know. And here's an email and also phone number that you guys can reach out and contact Millennium. And then they can kind of distribute where they want to reach out to and how we can continue to support you beyond the basic knowledge we learned today.
Yes, thank you everyone for being here today and joining us. A special thank you to David, Tim, and Frank for your wonderful presentation. I hope you all enjoyed it as much as I did and learned a lot more about micro technologies. If you have any last minute questions, please feel free to use the Q&A session, and we will again be sending you a link to the download as well as a link for a survey that we would greatly appreciate if you would take a quick 2 minutes to fill it out so we can make sure we enhance all of our future webinars. Thank you again so much, and I'm not seeing any more Q&As. And I'll wait just another more minute, but otherwise, you guys have a great day, and thanks for joining.
Thank you.
Thank you, everyone. Thank you, Jamie.
Thank you.
All right, I'm going to end it. And if you have any other last minute questions, please email us at info@mtpllc.us and we'll get those answered for you. Thank you.